Welcome to IoT Decoded number 5. IoT Decoded is a podcast about LPWAn technologies. We are on December 2019th and we are the day after Christmas. In today's episode, we are going to talk about different topics. The first one will be satellite communication with LPWAN, which is current actuality is booming on this topic currently. Then we will talk about the first LoRa bomb. Yeah, it is. Then some news, old news about Wi-Fi and St-Microelectronics new chips. And then we will conclude with the TheThingsConference information. So let's start with satellite. It's a topic we already addressed previously. So something that is not totally new, but this month this is booming a bit because we have different announcements. The first one is a Sigfox announcement. It's related to a company named Plastimo. They are making stuff for people having boats and for the security of people in boats. So they are in the middle of nowhere, middle of the ocean, and we need some time to position them to save them in case of accident. And so they decide to connect their software equipment and they decide to connect it with Sigfox, so Sigfox Elo, which is a satellite solution. Which is something interesting because Sigfox Elo is not yet existing. I mean, the satellite has not been launched, so they are really starting really quick on this. But it's interesting basically because Sigfox technology is really working well around the coast. Where you have something like 60 kilometers of coverage. So for most of boats, it's a sufficient coverage to be under network coverage. So that's interesting. And the satellite could be an option to be connected everywhere. And what is interesting is the technology for communicating with a ground base station or with satellite in Sigfox is compatible. So the same antenna. An horizontal transmission antenna is good enough to transmit to a Sigfox satellite. So the system, could already work even without satellite with the base station on the coast. And then when the satellite will be there, the system will be able to switch to the satellite system. The only difference basically is you need a system to detect the satellite and to be able to communicate when the satellite is just on top of you. So that's the main difference in Sigfox technology. So that was for Sigfox, but the more interesting actuality on satellite is coming from LoRaWAN ecosystem. We have two news this month I've seen. The first one is the Fossa-Systems. The Fossa-Systems, they have sent a CubeSat. It's basically just a LoRaWAN transmitter from the sky. And the CubeSat is a really small satellite, a 5 by 5 by 5 centimeter satellite. So that's really nice stuff. So not expensive also. And it is transmitting every minute a beep. It's like a Sputnik using the LoRaWAN technology. That's basically interesting, but it's really far from what we want to do because communicating from the satellite is, it's not really complex, basically. As the main issue with satellite is the reception, as you are far away, so in high altitude, so you are receiving a lot of noise coming from a wide area. So the reception is a bit complex, but the transmission is basically simple. You just have to transmit. But that's interesting. It's something if you want to have fun, you can try to get this signal from the ground, and so you can go to Fossa-Systems website and get the information if you want to do the receiver. Just be careful. You need to have the last Semtech transceiver to do that due to some specific preamble they are using. So the A612C6 need to be used for such reception. The main interesting thing, in my point of view, is the Lacuna-space experience. I've seen some nice tweets from Fabien Ferrero, who is a French guy, who made a transmitter and able to discuss with Lacuna-space system. So this transmitter is a bit specific because you have a directive antenna. This is a way you can communicate with Lacuna-space if you want to be received, because there is a lot of noise around, and you to be listened from this noise. It's better if the antenna is directive from the ground to the top to point directly the satellite direction. So he made it with a really nice antenna. I really like the design of the antenna. It's quite beautiful. And it has been able to reach this satellite, which was at 473 kilometer high, which means the satellite basically will have a life which will be short for this one. But it's a good altitude, and it was a good challenge. As LoRa communication is made for 10-15 kilometers. So here we are 474, and based on the discussion I had with Fabien, the quality of the reception was good, and he was able to make multiple communication with success, with no loss. So that's really interesting to see that. And it seems that the transmission characteristics are quite standard, even if in its last year TTN talk, Lacuna-space founder explained that you need some specific preamble to be able to cover the noise. So, but it's just configuration on a A612C6 device. So that's interesting. So it works, and that's really, really interesting. Currently, if you want to communicate with this satellite, the satellite is turning from North Pole to South Pole, and then back to North Pole, and benefits of the movement of Earth to cover the whole globes. So basically, the satellite is passing twice a day on every point of the globe. So you can transmit your messages twice a day. So if you miss it, you need to wait for 12 hours. But that's just for the test. If the system is working, Lacuna-space will send multiple satellites, and so you will have to wait less. But for sure, you will have to wait for satellite transmission, and it also means that you need to know when you have to transmit. So this communication need to receive an information from satellites to know when you are able to send the message to it. So I don't know exactly how it works for LoRaWAN and Lacuna-space solution. I hope we're gonna have some details on this. So we'll see that. Maybe we can take a look on a GitHub code which is available. Maybe it's explained, but I don't have the information currently. I know that Sigfox do that. They will have a beacon, and you will do the synchronization. And once you are synchronized, then you know that the satellite on top, you are transmitting. And basically, it might be the same thing for the Lacuna-space solution. So it's real, it's work, and basically it's really promising. So LPWAN satellite solution are on the way to go. That's really, really good. And 2020 is going to be a really interesting year for this. With I think that Lacuna-space will improve and send new satellite, and Sigfox will also send its satellite that year. So that's something really interesting coming on that topic. So let's go to some other news. The one which is, I don't know, it's funny or no, it's not funny, basically, because the term is not funny, but that's an incredible use case for LoRaWAN. In Hong Kong, police have arrested someone which has designed a bomb with you can remotely control with a LoRa communication. Yeah, that makes sense. You want to be far away from the bomb when you want to switch it on. If you want don't want to use a cell phone system and have a point-to-point communication, LoRa is a good solution. Yeah, that's sad, but that's real. We're talking about 50 meters of transmission, so I assume that the antenna or the journalist is really bad. But basically what we've seen on the photos I've made, it's a simple RFM 95 device, plus I assume something like an Arduino or something like that. So it's really a hacker approach, and it's not a surprise that this kind of stuff exists. And that's a bit sad, but I mean, technology is for the best and sometimes for the worst. Another news, which is quite a bit old now, but I didn't talk about it, and I think it's a really interesting thing. It's what is called the Wi-Fi ONPC. I didn't find exactly why PC is, but it's another name is Wi-Fi on-off noise, which is interesting. It's a kind of hokey communication using a noise to create long-range communication. So for Wi-Fi, long-range means 67 meter, which is not really long, but better than 15, 20 meters you can reach with a standard Wi-Fi. So that's interesting. The principle is to have a noise emission and eventually stopping this noise emission and reactivating it and so on. So by doing this, you can do a 1 and 0 and 1, okay, and you can have a bit transmission thanks to this. The frequency of the communication is 1 Hertz, so the communication throughput is only 1 bit per second. Okay, so it's not like a Wi-Fi extension for watching YouTube around the swimming pool. No. It's just a really low debit communication. But that's interesting. You may have a lot of use cases. I mean, Wi-Fi is good for house, but if you want to extend it to your garden around, it's really limited. But with this solution, you can keep a contact with something which is outside, and that's interesting. For example, if you have something that take care of your garden, a robot doing such thing, and you want to ensure that is still on the Wi-Fi coverage. So if he loses the Wi-Fi coverage with this on-off communication, he could eventually find where to be back on the Wi-Fi. So that could be interesting. It's also interesting if you just want to pilot a system which is an on-off system, or just, I mean, if you want to get some temperature or thing like this, you can use this in your garden with a really low bandwidth. So that's interesting. I don't know how they manage collision. I think it's a bit complex, but it exists. What is interesting is that it's only software update, so it could be deployed on an existing access point, and it could be verified. So the question is more, what will be the first? Will the access point manufacturer will implement this protocol, or to have a device available, or they will wait some device available for doing this? So that's always a question with a new technology. Who is the first to implement the solution to allow the others to use it? So something to keep in mind and to have a look in the next months. It could be interesting things. Some news about STM with at first something which is not also new, the STM32 IDE. Sorry, it's an environment based on Eclipse. And delivered by St-Microelectronics. So it's good because by the past, St-Microelectronics only really supports Kale and AR environments, which are quite expensive. And I mean, if like me, since 20 years, you are using open source compiler and you don't want to change, I was used to have Eclipse and non-official support of STM32. So now with QBDE, It's well integrated with CubeMX, and that's great. The environment is really easy to install, work well on Mac, and is really stable, as much I have seen in the previous weeks. So thank you for doing this, ST. It's a great thing to support this environment and to deliver it. On the ST news, something really more interesting and really new is the STM32-WL. So that's the first SoC including STM and LoRa Semtech SX126X transceiver, which is really interesting because it means in the same chip you can do a powerful code with your ST chip. You can have LoRaWAN, LoRa for sure, and Sigfox, because the Semtech chip is able to do Sigfox. So in a small piece of plastic, you can get everything. So that's interesting. And the STM32 is a L4, which is Cortex M4. So really strong MCU. It can be single or dual core. So it's a really powerful system, including the LoRa and Sigfox communication. So that's really interesting. I don't have information yet about pricing and availability because I just seen some screen capture of slides in a conference or in a website in Chinese. So we have to wait a bit to get the details, but it's really promising. Just hope that it's going to be something like $4 or something like this. And I think it's not a good news for Murata and this ABZ chip with an unpronounceable name, because it's really an interesting competitor. So and it's going to be less expensive. So let's see that. Good news. Stay tuned on this topic. I really want to test it, and I hope that it's going to be available with DevKit quickly to do that test. To conclude this podcast, we have the TheThingsConference starting on 30-31 of January. It's going to be in Amsterdam, the place where the Thing Network has born. And it's going to be a really good conference. I hope so. I will be there. So I hope it's going to be a really good conference. There is 41 speakers. Just hope that another one will come, because 42 is the right answer normally. But okay, 41 speaker. And I've seen 3 different main categories of speaker and topics. We have, the Thing Network is a hacker community. I can say that. I mean, most of the people doing stuff on this community are hacker or things like this. And so we have speaker from KiCad, the PCB designer software, Microbit, Coitech, the solution for measuring current and when you design microelectronic, HiveMQ. Okay, so they are not really people coming from the LoRa ecosystem, but it's more the maker scene. So it's really interesting to see them at this place, because there's not a lot of great opportunity to meet this kind of people. So the TT conference is a great opportunity for that. So it would be really great. But for sure, there is people also from the LoRaWAN gateway manufacturing with rack that will be there. Semtech for sure, and Laird also will be there. So interesting discussion and talk, I think, around the evolution of the different gateway environment, and also the hardware solution coming from next year. And the last topic is about satellite with a talk from Lacuna-space. So we're going to get the updates. And also Fabien Ferro, I've seen the guy I've mentioned to have made the first communication with the satellite, will be there. So I'm sure that he will talk about his experience on this, and that will be quite interesting. So that's the end for this episode. The next episode, maybe at the beginning of February, it will be an episode dedicated to the TheThingsConference. I will be there. I will be there as a speaker. And if you join the conference, yeah, please contact me. I will be happy to share a beer with you. And so up to this next episode, I wish you a great Christmas, a great end of 2019. And for sure, if you listen to this podcast with some day of delay, I wish you a really great new 2020 year.